Hi GOH, this is Unit 5, Lesson 10, and today we're going to talk about coordinate geometry proofs. So this is something that we're going to do more of in the next chapter, but I just wanted to introduce it right here. So we've been talking a little bit about this throughout this whole unit. Coordinate geometry proofs are not regular proofs. There's no statements and reasons. Basically, we're using the coordinates. We're using either the slope, the distance, or the midpoint formula to prove something. So we did this a little bit with triangles. So in this exercise 1, I have a quadrilateral. A quadrilateral just means it has 4 sides, and I want to show that this is a parallelogram. Now we're going to talk more about parallelograms in the next chapter, but basically a parallelogram, the definition is that both opposite sides are parallel. So if I could prove the top is parallel to the bottom and the left is parallel to the right, then that would make it a parallelogram. And the way that I can show that those sides are parallel is if they have the same slope. So I'm going to find the slope of RS, I'm going to find the slope of TU, I'm going to find the slope of ST, and I'm finally going to find the slope of RU. So I have to use my slope formula 4 times. And if both opposite sides have the same slope, then the lines are parallel. So looking at RS, so just make sure you're taking the right points. Remember, slope is the change in y, so 6 minus 3 over the change in x, 9 minus 0. So that's 3/9, and I'll reduce that to 1/3. Then I'm going to find the slope of TU, which is the bottom. So again, the change in y, negative 2 minus 1 over the change in x, negative 3 minus 6. That's negative 3 over negative 9, which also reduces to 1/3. So far so good. The top is parallel to the bottom because they have the same slope. Then I'm going to find the slope of ST. 1 minus 6, change in y, over 6 minus 9, change in x. Negative 5 over negative 3, which reduces to 5/3. Okay, and then the slope of RU, just make sure that you're looking at the right points. RU is negative 2 minus 3, negative 3 minus 0. So that's negative 5 over negative 3, which again reduces to 5/3. So this is is it a parallelogram? It definitely was a parallelogram. It says prove it's a parallelogram. So I would just need a short little statement. RSTU is a parallelogram since both opposite sides are parallel. Again, this is a coordinate geometry proof. You're using slope, distance, or midpoint to prove something. And then I just have a short little statement. It doesn't even have to be a full sentence saying why you know it's a parallelogram. So I have the work there, but I have to say what that work means. All right. Using the midpoint formula, they want me to find the midpoint of the diagonal. So I want to find the midpoint of RT. Okay, so the midpoint of RT, let me put this down a little bit so I can see the points R and T. So the midpoint of RT, so midpoint, I add the x's, divide by 2, and I add the y's and divide by 2. Make sure you're doing RT. So that's 6 over 2, which is 3, 4 over 2, which is 2. Then I'm going to find the midpoint of SU. Again, make sure you're taking the right points. So I got SU, I could have highlighted the other ones too, and I have RT. So the midpoint of SU, so I'm going to add the ones I have highlighted in yellow. 9 plus negative 3 divided by 2, and 6 plus negative 2 divided by 2. So that's 6 over 2, which is 3, and 4 over 2, which is 2. So basically, they have the same midpoint. All right, if these two diagonals have the same midpoint, they have the same midpoint, right? I didn't do a great job. 1, 2, 3. It's really over here. If they have the same midpoint of 3, 2, that means that they bisect each other. Okay, since they have the same midpoint, the diagonals bisect each other. So right now we're discovering some of the properties about parallelograms that we are going to learn in the next chapter. The definition is that both opposite sides are parallel, And we now have learned that since they have the same midpoint, those diagonals bisect each other. So that's an important property. All right, exercise 2. I want to calculate the slopes of all 4 sides, and I'm going to use these slopes to prove it's a rectangle. So I want to show that EFGH is a rectangle. A rectangle is a parallelogram with one right angle. And again, we'll talk about these properties more in the next unit as well. So basically, again, I'm going to show it's a parallelogram by doing the slope 4 times. And then I'm going to show it's a right angle also by the slope. Because if it's a right angle, then those lines are perpendicular and the slopes would be negative reciprocals to each other. All right, so I'm going to find the slope of EF. So look at points E and F. Those are the first 2 points. Y minus Y, 8 minus 2, 3 minus negative 6 is 6 over 9, which is 2/3. Then I'm going to find the slope of GH, okay, the third and the fourth point. So it's going to be negative 4 minus 2, negative 2 minus 7, negative 6 over negative 9, which is again 2/3. All right, so far so good. The top and the bottom have the same slope. And maybe I'll switch colors up here. And then I'm going to find the slope of the left side and the right side. So I'm going to find the slope of FG. So make sure you're doing FG. 2 minus 8, 7 minus 3. So that's negative 6 over 4, which is negative 3/2. That's the right side. And then I'm going to find the slope of EH, which is the left side. Negative 4 minus 2. Negative 2 minus negative 6, so that becomes a plus positive, which is negative 6 over 4, which is negative 3/2. Okay? So you can see that, yes, this is a rectangle because the opposite sides are parallel, and it also has a right angle because these slopes are negative reciprocals. Look at these slopes right here. This side is 2/3, and this side is negative 3/2. So since they're negative reciprocals, that means those lines are perpendicular, and it is a right angle. All right, let's calculate the midpoint of the diagonals. Why does this show that EFGH is a parallelogram? So again, the midpoint of the diagonal. So I'm going to find the midpoint of EG and the midpoint of FH. And I want to show, why does this show that it's a parallelogram? So I got EG. I'm going to add the x's, negative 6 plus 7 divided by 2. And I'm going to add the y's, 2 plus 2 divided by 2. And that gives me 1/2 and 2. Then I'm going to do the other diagonal, the midpoint of FH. Again, I'm going to add the x's, 3 plus negative 2 divided by 2, and 8 plus negative 4 divided by 2. And again, it's 1/2 and 2. So this is a parallelogram because the diagonals bisect each other. Since they have the same midpoint, the diagonals bisect each other, and we just learned that up above, that a parallelogram, the diagonals bisect each other. All right, and then they want us to find the length of the diagonals. So again, the length of the diagonals. So E is the point negative 6, 2. And I want to find G, the length of EG. I'm just writing these points so I don't mess it up and take the wrong points. So that's going to give me 7 minus negative 6 squared plus 2 minus 2 squared. Okay, that's 13 squared, and 2 minus 2 is just 0. All right, so this is a little bit easier than I thought. 13 squared is 169, which equals 13. And then I'm going to find the length of FG. So I'm going to write the coordinates down for F and G, right? Oh, FH, sorry, FH. Just so I don't mess this up. So I got F and H, and I'm going to find the length of FH. And this was EG. All right, so FH. Again, I'm subtracting the x's. Negative 2 minus 3 squared plus negative 4 minus 8 squared. So that's negative 5 squared. and negative 12 squared. Negative 5 is 25. Negative 5 squared is 25. Negative 12 squared is 144. And 25 and 144, same number, 169, which is 13. Now we're going to learn in the next chapter that the diagonals of a rectangle are congruent to each other. All right, look at these. They're the same length. So in a rectangle, the diagonals are congruent. Okay, so we're just going to practice a little about that tomorrow. I just wanted to show you some coordinate geometry proofs, but we're going to deal more with those properties of parallelograms in the next chapter in more detail.